In lesson 4.2 activity 1, we're going to be using the substitution method to solve these systems. So since they say to solve it algebraically, all I have to do is do some algebra. I don't graph anything here. And since they want me to do the substitution method, I have to have one of the variables isolated to plug in the other one. Here, the d is already isolated, so you can think of it as all I'm doing is plugging d's value into the other one. Or since d is equal to this and d is equal to that, these guys must be equal to each other anyway. So 65t must be equal to 300 plus 50t. Again, all we did was set the two d values equal to each other. After that, let's isolate t. So we're going to get the t's on the same side. 15t equals 300, divide by 15, and it looks like t is equal to 20. But I'm not done because I have to find d as well. So since d is equal to 65t, I'm going to go ahead and choose to plug it into the first equation because it's easier to work with. So this t value got plugged into here, into equation 1, and we end up with d equals 1300. So we got both pieces, and as an ordered pair, we would get input is t, output is d, t comma d, t is 20, and d is 1300. Part 2, we're still doing the substitution method. So they give us the suggestion of what to do, but we should also know what to do ourselves. This is equation 1, this is equation 2. Since x looks loneliest, that's the guy I want to isolate in equation 2. It'd be the easiest thing to do, isolate the loneliest variable, and that's what they want us to do, solve the second equation for x in terms of y. So I'm going to take the second equation and get the x by itself because that's the quickest thing to do out of the two equations. Once I have that, it says substitute your expression for x into the first equation. Yep, I need to get this guy and plug it back into the equation that I have not used yet, which is equation 1. So I have 3y minus 2, drop in the expression for x, 2y minus 2 equals 3, and then simplify, so distribute the 2, that's minus 4y plus 4, negative and negative make a positive, equals 3. 3 minus 4 is a negative 1y, plus 4 equals 3, subtract 4 from both sides. That's a negative 1y or negative y equals negative 1. Divide both sides by negative 1, I guess, and it looks like we end up with y equals a positive 1. So we isolated x, we substituted that expression back into equation 1, we solved the result that we got, and we got y equals something. Now I have to substitute it back into step 1, into here, back into the cloud to get the value of x. So x equals, from the cloud, 2y minus 2, but we just found y to be 1. So I guess I end up with x equals 2 minus 2. X then must be 0. So we found the value of x as well. Last thing I got to do is check to verify to make sure the 0, 1 I got actually works for both equations. So let's go plug those in. So when I take x equals 0 and put it in equation 1 right here, and y equals 1 and put it in equation 1 right here, the negative 2 times 0 cancels out, and I get 3 equals 3, which, yep, is a true statement. So the solution works for the first equation. Let's double check to make sure it also works for the second one. So once I put the 0 and 1 and the x and the y value in equation 2, I get negative 2 equals negative 2, and that also checks. So we verified our solution. We've solved it correctly because the ordered pair works for both equations.